This is problem 7-20 in section 7.1.2 homework. It says in 1998, Terre Haute, Indiana had a population of 72,000 people. In 2000, the population had dropped to 70,379. City officials expect the population to level off eventually at 60,000. That's important. What kind of function would best model the population over time? So our types of functions we really talked about this year are linear, we've talked about parabolas, which is quadratic, and also exponential. So those are either increasing quickly or decreasing quickly. Now this one kind of should remind you maybe of Dr. Deadman when that day we did all those, that big fun like story problem, murder mystery, and his body temperature leveled off at, I think it was 17 degrees Celsius or something. So that's kind of cluing me into, since it's leveling off, it's decreasing from between these two amounts, but there's a leveling off point where it never crosses 60,000. So that's going to be an exponential function with an asymptote. And pardon the poor handwriting. This is very first videos, unlike Mr. Boyd, who is very experienced and professional at these. I promise they'll get better. So it's going to be exponential, so that formula is y equals a times b to the x power. Now in this case we have an asymptote, so we're going to write in plus k. The book previously called it c, but we've been talking about k when we talk about translations, so that's a vertical shift, up is the k. So what we're going to do, it says write an equation that would model the changing population over time. We're going to plug in the values that we know. And as of 1998, the starting point of the population is 72,000. So I'm going to have that kind of be a point. My starting point is 72,000. Now we're talking about from 1998. So 72,000 isn't really the start of the population in people ever in this town in Indiana, but from this value, from this point in time, from 1998, it is. So then 2 years later, it's 70,379. That's why we have a 2 there. It's 2 years later. Okay, so we're going to plug those numbers into our equations up here. We're going to have two equations. So y, which is going to be 72,000, equals a, we don't know that, times b to the 0th power, that was x, plus our asymptote, which was at 60,000. So we need to include this. This is what a lot of people forgot on our last chapter test. Our second equation has a y value of 7,379 equals, again, I don't know my starting value, I don't know the multiplier, but the x value is a 2, again, plus my 60,000 asymptote. It never goes below 60,000. So first thing I need to do, I can't start canceling things out or dividing right now because I have this number in both of these. If that was gone, then I could divide possibly both of these values. Now something we also know is b to the first power is really worth 1, or anything to the first power is worth 1. So this kind of tells me right away I have 72,000 equals a plus 60,000. So if I solve that one, jump down here, 72,000, and I'm going to subtract 60,000, tells me a, which equals 12,000. Again, apologizing for the handwriting. So this is my starting value. That's also important information. We know our a in our equation. We know a. Now we need to find the multiplier. So without actually canceling anything out, we can get the answer to this problem. So I'm going to plug into my second equation right here. My 70,379 equals, now I'm going to plug in this value for a. 12,000 times b raised to the second power still, plus 60,000. I only plug in the value for A. So from here, trying to get B by itself, I need to solve for B. I know what A is already. And subtract 60,000 from this. Subtract it on the other side as well. So what we have left is going to be what we have left is 10,379 equals 12,000 times B squared. Okay. To get rid of this 12,000, this is really multiplication, right? So we're going to do the opposite of multiplying. To get the B squared by itself, divide by 12,000 on both sides. So that will turn out to be about 0.865. We can round it there to 3 decimal places. That equals B squared. Now to undo the squaring, I'm going to take the square root of both sides. I'll make sure this is a decimal. There we go. So we're going to take the square root of about 0.865. And we're going to get 0.93 is B, or my multiplier. Which makes sense because the population was going down, if you remember. It's going down, so my multiplier needs to be less than 1. So that is a good thing. So here's my multiplier. But the question says write the equation. So we have our A value right there, 12,000. We know our asymptote is at 60,000, and now we know the multiplier. So our final equation to represent the population of Terre Haute, Indiana, y equals my starting value. Now this is kind of if the population was starting from year 0. That's what the starting value means, because you're saying, what, the starting value, we wrote a point of 0,72,000. Well, we said that was from 1998. This is from starting from year 0. So here we have our starting value was the A right here. This is our multiplier. It's going down. And this is our asymptote. It goes closer and closer to 60,000, but the population never goes under that. So that is our final equation.